So let us talk about the network design. So when network design is concerned, we are concerned about two main things. One is reducing the cost and minimizing the distance. So when it comes to reducing the cost, we have two algorithms like Prim's algorithm and Kruskal algorithm. And when it comes to finding the shortest path, uh, we go for algorithms like Dijkstra's algorithm, Floyd's algorithm. So the difference is Dijkstra's is single source shortest path, whereas Floyd's algorithm is all path shortest path. So let us discuss how minimum spanning tree can be constructed to reduce the cost of a given network.
So at first we are gonna see about minimum spanning tree. Minimum spanning tree nothing but all vertices are connected, but it has a minimum number of edges. For example, let us take this bundler. We are counting local letter for all the system. By counting this, we don't need we minimum the cost of the.
We don't prefer the distance.
Distance, but we need to connect all the systems. But so we go to minimum spanning tree. In this minimum spanning tree, we does not no loop will be formed. We just needed to connect all the vertices. We have a path. So in minimum spanning tree, it has two algorithms, Prim's and Kruskal algorithm, to make this chart this path.
So let's see an example.
Let's construct the example of minimum spanning tree. A distance between D and E, D, A is 1 and A and C is 2. C and D 3, A and B 4. It is the structure of minimum spanning tree.
So for this given example, this is the minimum spanning tree.
So from Sunday dawn, we can see that many edges is not connected. Only from A to B is connected, and A to C is connected, and C to D is connected. We have to assure that all the edges are connected. Then all the vertices connected. Then it should not form a loop. Only minimum number of edges should be connected. We have to assure that all the edges are connected. Then the difference between minimum spanning tree and Dijkstra's algorithm is in minimum spanning tree, you have to not form a loop-like structure or cyclic structures. In Dijkstra's algorithm, we can form cyclic structure.
The graph may have cycle, but at minimum spanning tree will not have a cycle. So let Srigar explain. Sharvin explain about Dijkstra's.
So now we are going to see about the single source shortest algorithm. So this is going to be your diagram. Here the diagram have already been given. So now we are going to see the distance between the places. So here we are going to take a place 1 as a A. Then see A goes to which direction and which vertices. So here A goes to the 3 vertices C, D and D. So we are going to see the shortest one. So we are going to see A goes to
from A to B.
From A to B it's 4. So from A to B it's going to be 4. Next we are going to see the A to C. The A to C is going to be 3. So next the A to D is going to be,
we have 3 different paths to
A to D is going to be 4. Here it is taken because of we have 3 different paths to go from A to D. The path 1 is going to be A, B and D. The second part is going to be straight from A to D. The third is going to be A, C to D. But we are going to take it as the shortest path. So here the shortest path is going to be A, C and D. So this is known for the single source shortest algorithm.
Then let us see the real world application of both the minimum spanning tree. This includes Kruskal and Prim's and the Dijkstra algorithm. The Kruskal algorithm is basically used where the electrical wiring networks are created. Because in electrical wiring networks, we prefer with the minimum cost with the most efficient works. So we go with the Kruskal algorithm. Whereas Dijkstra is used in such as Google Maps or any other location-based service softwares, because we prefer shortest distance moreover than covering all the areas.
So as we have seen, you could have observed one thing. So when we want to apply minimum spanning tree, the given graph has to be a connected graph. Only if the graph is connected, we can apply minimum spanning tree. So it is, and as Syed has said, we have two algorithms for constructing a minimum spanning tree. One is Prim's and Kruskal. So irrespective of the algorithm we are using, the final outcome is the same. So the final minimum spanning tree constructed will be the same for both the algorithms.